Okay, we had our polar bear launch just on Sunday. Right now it's Wednesday afternoon. And it was a nice day, at least reasonably nice. It was 29 degrees, very light winds, so it was a good day for launching rockets. I launched 12 rockets, and many of them were experimental streamer designs, as I like doing. But I'd like to show you some things that happened unexpectedly. Namely, I got some damage on some of the rockets, which may necessitate some design changes. So let me show you what I'm doing and what happened. And I got 3 rockets that have damage. The first one was the Dragonite, and this one had a 4-inch streamer in it, so it's got a very long, narrow blanket. If we take a look at the streamer, though, when I got home, I was looking at the streamer and went, hey, wait a minute, I've got a problem here. You can see that this streamer tore unexpectedly right here. Now, what's strange is it tore in the middle. It didn't tear at the end. It didn't tear at this end. So somehow, in the middle of this, it just suddenly pulled apart. Unclear what happened. Situations like this, I'm really not sure what happened, but it's easy to repair. At least there's no damage further down on the streamer. So all I can think about is that this front end must have been whipping around very, very rough, and somehow it just caught a kink and just snapped and pulled apart the streamer. So you can see there it is again. So what I'm going to do is just simply slice this off with a knife and take out the streamer mount on the front and just tape it back on down here. So all that happens, I just lose about 8 inches worth of length, and everything should be okay for another flight. Now there's another situation that seems to be happening, and as the streamers on the larger rockets are going more straight and not fluttering enough. And if you think about this, I've got the long cord here, typically about 5 feet long. Then I've got another long cord here, another 2 feet before we hit the streamer. So the streamer is whipping around, but none of that is really translating down to the rocket. So what I found is that on a different launch, with the streamer much lower, that the tossing of the rocket tossed the streamer, and it almost had a tumbling effect of the streamer in midair. It was actually very interesting, and it fell very slowly. So I'm going to be modifying this design to reattaching the streamer right at the swivel. And there's a special knot for doing that. Of course, everything has a special knot, but I'm going to show you how to do it. So let's take a look at another rocket. This is one of my favorites, the Astra, or Venture. This is a new one that I built, and I put a C65 in it, so I put this one up really high. And I had this 1-inch streamer, and as you can see, I got the nose cone in this hand with the rockets over here. And this landed in the field. I just picked it up and put it into a plastic bag like I do with most of them, and I threw it in the car. And then later, a friend of mine was walking through the field looking for his rocket. He goes, hey, I found a nose cone. Isn't that interesting? I went, isn't that interesting? I just lost a nose cone. So what was interesting is that he was downrange about 400 feet, and I heard a thunk. I looked over, and this nose cone, of all things, if you look at the field in the other videos, you'll see there's plants, bushes, shrubs, and it's hilly. And for this little nose cone, I guess about maybe 3 inches long, to fly about 400 feet downrange and land next to a person who's actually looking for his rocket was just an incredible coincidence. So he goes, hey, here's your nose cone. If we take a look at what happened over here, see, this is where it was attached. So this loop goes back to the rocket and goes back to the engine mount where it's mounted. So the stress should have thrown the streamer out, but it looks like the stress being on the nose cone, it pulled this loop right through, and then it threw the streamer out. So the streamer opened beautifully on this, and here it is right here, a nice 25-foot streamer. Had a great recovery. And the interesting thing is that because the nose cone is not directly connected to the streamer, in other situations you can sometimes see, if the shock cord breaks, the nose cone floating away and then the rocket tumbling down usually gets damaged. In this second situation, the nose cone section actually flew down range. Nose cones are fairly easy to repair or replace. And instead, the streamer stayed with the rocket, and the reason is it's connected to the swivel here. Everything's connected quite tight. And all I have to do is just untie this and tie it back through the nose cone when I repair it. The question is, how do I repair this? I don't know if you can see that very well. But this cracked, if you can see that crack, there's a crack right there. So essentially the Kevlar cord just pulled right through this. And that's very unusual because this cord is doubled and it's the thick cord and it's still cut right through the nose cone. I had this happen on other rockets with much larger nose cones. I speculated that they just weighed too much. But this nose cone doesn't weigh anything, so its zippering is really highly unusual. So to fix this, and I'll just fix this later off camera, I'm just going to take a toothpick and just glue it on here. Probably use some E6000 because it's a little bit more rubbery. And then at least I'll have space underneath this to put the loop through again. So I can just tie it back on like I always have. And this will be glued on right across this entire area where it tore through in the middle. Now the thing is, that will be reasonably good for absorbing the shock on the crossbar part of it. However, these areas are also subject to tearing. So in this case, I might put some glue along the edges. And yeah, it might start looking a little messy, but I think I'm going to have to do that if I want to keep my nose cone. In other situations, I just cut this particular little eyelet off, and then I drilled a hole. I drilled a hole on this side and on this side. I fished a wire through it, and I put a piece of Kevlar cord through it, so I had a Kevlar loop on the nose cone with this entire area here to help dissipate the shock. So again, losing a nose cone is kind of a screwy thing. It's like, what do? Do you go buy more nose cones, or do you throw away the rocket? I had a situation where the nose cone had flown away, but I actually had a different rocket. I just started switching nose cones. But anyways, again, this is a very good launch. It was on the C65, and I don't know if maybe the C engines are more powerful in their ejection, assuming it's a bigger rocket, but this is a very small rocket, and the C65 ejection just tore the nose cone right off. Again, an active fate, there happened to be a person downrange looking for their rocket. I just happened to get my nose cone back. It doesn't happen very often in an area like that. The last situation, a high flyer, again, it had an absolutely incredible flight. It looked very, very good. And came down, and I picked it up. I go, hey, wait a minute, I'm missing something. Well, if you look at the cord here, you see that little crossbar piece pulled right off. Now this one was one of my earlier designs where I actually glued the Kevlar cord right onto the crossbar piece so that it would not scissor through. And yet it just pulled the entire crossbar piece off. So this is kind of crazy. It just means that the ejection energy was so high that even though this didn't scissor and cut through it, it just tore the eyelet right off. And again, I've had larger rockets too do that. Some nose cones on some 24mm rockets, and the rocket was about almost 3 feet long, and the nose cones tore off. I had that happen to like 3 or 4 of them, and the answer was to drill holes through the nose cone, put the Kevlar cord through it. I'm going to again try a slightly different idea and speculate that the ejection energy is hitting the eyelet and tearing this off before it releases the streamer. So the whole idea of putting the streamer out here with the nose cone is that the ejection energy is going to throw this out, and then it's going to let the streamer keep on flying and let it unwind very quickly. But I think what's happening is before the streamer gets a chance to get out, it's just yanking right in the nose cone and pulling it off. Luckily, I do have another nose cone. So the nose cone was from a different high flyer, which got severely damaged, and I didn't fly it anymore, so I have another nose cone. I'll just simply put this on in place of the one that I lost. I don't know what happened to the one that came with the rocket. But you can see this is a very unusual thing to have the glue on the crossbar pulled right off. So think about that, just pull this whole thing right off. So I'm going to again put this on. It looks like the glue strengthened this, but I need to strengthen the sides of it with a little bit more glue too. Anyways, I'm not too motivated to keep strengthening things with glue. It is just kind of a messy hack, and you never really know how much or if you have enough. So I'm going to be again moving my streamers to a different location, trying to get the streamer to absorb the shock of the ejection rather than having the nose cone tear off. So 2 flights, and I launched 13 times. 2 out of 13, that's pretty high. You don't want to have your rockets getting damaged. Okay, so I'm going to go repair all this stuff and get ready for another launch coming up on March 8th. Look at a different way to attach the streamer. This is the Dragonite. I just flew it on Sunday. I had a really great flight on a C65. This had the 4-inch streamer, and the previous video showed that the streamer had a split in it, so I just took a knife, cut about 6 inches off, and reattached it, so I'm all set to fly again. a very easy repair. However, I'd have to take a look at this and say, okay, what caused the problem, or why is this problem happening? So there's actually two things I want to do. One thing I'm seeing is that the streamers are opening up beautifully, but with this long cord, the rocket is dangling around and the streamer is staying still. And when it stays still, it doesn't flutter, and that's causing it to fall a lot faster than expected. And what I'd like to do is to move the streamer closer to the rocket. This way, as the rocket moves back and forth, the streamer will flutter a little bit more, or burn up a little bit more energy, and it will fall a little bit better. I did an experiment similar to this with one of my other rockets, where I tied the streamer down low as a little, just a spotting streamer to help me spot the rocket, and I noticed how it fluttered so much better. So I've been modifying things for the last couple of days for a new launch coming up on March 8th, and we're going to be launching for a particular club. And I've been invited to say, hey, can you fly some rockets with some really cool streamers? So I'm changing all these streamers. Cool depends on whether they work or not, so we'll just have to see. But again, if we look at this from an engineering perspective, I've tried mounting it here, and with the nose cone is far away like this, it falls and the streamer straightens out with the body turning horizontal. The body does lose some speed because it's horizontal, but the streamer does not really slow down as much as I would expect. So here's the trick. Earlier, I showed how to attach this, where I had this piece of heat shrink over the swivel, and it's still there. I've not had any problems. It's still there after several launches. I can pull it off if I want. But what's nice about this is that this loop is fairly large. So you can see I have space behind this to attach the streamer. And then if I want, I can just detach the streamer, and I can pull the heat shrink back and detach this knot. Again, everything can come apart fairly easily. It's one thing that I like. But I'm going to tie a special knot to tie the streamer on, because I don't want it sliding around, and I don't want it on just one of the cords. I want it on both. So the trick is, how do I tie this onto both cords at the same time? Well, the trick is this, and I just kind of, I guess, invented this as I was working with these cords for so many times. What I'm going to do is I'm going to put this down through this hole like this. Now it's off to my right, and then I'm going to pull it underneath and back up. So I'm going to pull this underneath and back up. It's going to be like a figure 8. I know it's hard to see. It's also very hard to hold, as I'll often talk about how springy Kevlar is. So you see, I pulled it down through. It is hard to see. I pushed it down through. That's maybe a little bit easier to see. Then I pulled it back up through the loop again. And now I'm going to just simply push the streamer through the loop like I always do. However, note that we want to have this cord in between the loop and the streamer. If you pull it through from this side, it's just simply going to unwind the knot. Pull it through from this side, makes a figure 8 on the knot, and the figure 8 now is going to give us a nice tight fit. So let's go ahead and pull the streamer through. Okay, so essentially what this knot, it looks fairly complicated, and I guess it is. What I'm going to do is just pull this tight. Well, see, this knot now is a very, very large knot, and it's very tight because it's putting both of these two sides of the cord to these two sides, and it's just putting them together into like a figure 8. What's also interesting is that this knot doesn't seem to slide around. So even though it's Kevlar, it's staying put. So now I have this knot. So now when the streamer is up in the air vertical and fluttering around, the rocket's going to pull it back and forth a lot more, and the force of the streamer is going to be acting directly on the rocket. Before, the force of the streamer was being absorbed on the nose cone would stabilize, the streamer would stabilize, and we don't want stabilization. We're coming down. We want everything to be unstable, so we have a lot of drag. So now again, winding this up is the same way as before. We just simply wind this up using the figure 8 method, or the over-under method. We drop the streamer in, fold it, and put it in, and we're done. So now you can see I'm ready for flight. I had 2 changes. I had to modify the streamer because it was cut in the middle, it tore in the middle. Took about 6 inches off and just put the mount on the front. And now I've moved the streamer down to this point. What's really nice about using Kevlar like this, and I've talked about this many times, and I also emphasize it many times, is that you can really experiment with a lot of different things. And there's different size streamers. You got this 4-inch streamer, you've got this 1/2-inch streamer. And mounting them, there's various places to put it, different things to experiment with. So go ahead and play with it and see what works for you. So I think what's going to work better for me is that I'm going to have the streamer pulling on the rocket rather than pulling on the nose cone. This may also help the nose cone zippering problem that I had. It didn't zipper on this one, but with the streamer here, I think that streamer might be giving an extra yank, and it's going to tear the nose cone eyelet off, because I had 2 flights where the eyelets did tear off. Again, not this one, but this one did have the torn streamer. So that's it. That's it for repairs. I'm going to put things back together. And this should be a very spectacular flight. I'm going to probably put a D16 in this. It's going to be an extremely high flight. And with an extremely high flight, the streamer should look very, very nice. There's always the challenge of flying in that very small field in the middle of a forest preserve area, nature preserve area. And there's a lot of obstacles. But hey, that's what's fun about model rockets. You're trying to design your stuff so it's somewhat predictable, and you figure out where it's going to go. So hopefully I can get this to drop relatively close to our park area. Okay, so that's it. Again, very interesting changes, but be a rocket scientist and experiment with it and see what kind of changes you can do with your streamer width, your length, your size, the mounting positions, how you wind it. A lot of fun things to do. That's why they call me Mr. Streamer, and I have fun building and trying things. The Venture rocket. I launched this one on our polar bear launch last week. Temperature was about 29 degrees or so. Pretty cool, but it was a very nice day. I launched this rocket on a C65, so it went incredibly high and had a great flight. It came back with the streamer just a few feet, I guess around maybe 50 feet from the launch pad, which is pretty good considering how high it went. But I noticed when I got it back, I had this little problem. Namely, the nose cone was missing. I got the nose cone back, surprisingly. The nose cone had flown several hundred feet downrange and just happened to land next to a person looking for his rocket, which is really kind of comical because he says, yeah, I was looking for my rocket, I heard a thunk, I looked over and there was a nose cone. So I said, yeah, well, that's my nose cone. So everything worked out just fine. But what had happened was that the Kevlar cord had zippered through here, and the way I fixed this is I took a toothpick and I glued it on with some CA glue to kind of stick it down. But then I put some E6000 glue on this. The E6000 glue is a little bit more rubbery context to it. So this now is really a strong connection. I'm a little surprised that I've got so many issues with the nose cones the last couple flights. The other one, the entire eyelet was torn off completely. This one zippered through. Now, it's unclear if this happened on the ejection charge or if this happened during flight. During flight, it's possible because the streamer is connected to the eyelet is connected to the nose cone, so obviously if the streamer is yanking the eyelet around, it could be yanking the nose cone and eventually zipper through it. So I'm not really sure which of the two situations occurred, but in either case, I've got to start thinking about how to fix this, how to make some changes. So you see again, this fix looks really nice. It's quite strong. The toothpick in there, the E6000 is really tough glue. It's a polymer glue, which means it's got the strength of an epoxy. So it's very, very strong now. So let's take a look at how we're going to change the rocket connection here. So in this particular rocket, I actually tied a slip knot onto this, and I pulled this down tight, and I put the heat shrink over this directly. So you can see it's a very nice, clean connection, and we're going to work with this in a moment. But let's go ahead and reattach the nose cone. And the connection to this is very simple now. We're just going to do what we did before, place this through the eyelet, and then place this through the nose cone. And I've done this several times in plenty of other videos. And this knot just pulls right through here. So now we're going to place the nose cone and the felt blanket through the loop. Oh, by the way, I do have the streamer disconnected. It's right here. I just untied everything just so that I can put it back together a little bit differently. So now we got the nose cone and the blanket. I'm just going to push this through the loop here on the end. That transfers the loop now onto the cord. So now you can see I've got the loop here, and that goes through the nose cone and the blanket. I just keep on pulling this back through. So I'm going to pull the knot back through both of these now. So I've got the knot over here. I'm just going to pull it back through the nose cone, pull the knot through the blanket, and then just pull it tight. So I did the same thing I've done before. The difference is I'm not going to attach the streamer here this time. I'm going to do something a little bit different. So that's what's different about this particular situation. So what I'm going to do now is just tie a knot. I'm just going to make a loop like this, so a very simple loop, and put the nose cone through it, but only the nose cone, and then pull it tight. And you may have to work, that knot may snag a little bit, and just pull that back through here. But you see now we've got a nice strong connection here, and this will hold it next to the nose cone. Look what we were looking for before. And again, I may need to work this a little bit more. There's that knot that we're working with. I may need to pull that around through the knot a little bit more, or through the loop a little bit more. But that's okay. It'll work like this. So what am I going to do with the streamer? Well, again, there's two issues that we may be thinking about that could be causing a problem. One is with the streamer on here, that when the streamer flies out, it puts a hard yank on the nose cone from the injection charge and it tears the eyelet off. Maybe that's what's happening. Maybe just during flight, as it falls down with the streamer hooked on here, it's bouncing around the nose cone, which puts a lot of stress on it. Maybe that's what tore the nose cone off. I don't know. But let's go ahead and try to do this a little bit differently. I'm going to attach this streamer back here. And this is going to do two things. It'll put the ejection charge energy and the shock energy from descending, or the flight energy from descending. As it pulls around with the streamer, it's going to pull around directly in the body. So it's going to have the body closer than the nose cone. So the nose cone now just going to be free falling along the side. But most of the resistance effect of the streamer is going to be directly on the rocket body. So I'm going to do this by just making a simple overhand loop in here, or a fisherman's knot. It goes by various names. Just simply take the cord and make a simple knot in it like this. The nice thing about using knots in Kevlar is that you can change it around real easily. It's a real easy change to make. And there we go. Now I've got a knot, and I can connect my streamer to it. And you don't have to put any CA glue in this or anything. It's going to hold extremely tight. In fact, the more you pull on it, the tighter it's going to get. But even though you can pull this incredibly tight, this Kevlar makes it easy to pull apart. So you just basically put a tight little grip on the knot, and it will pull apart. Okay, so let's take a look at how we can attach the streamer to it. I'm going to use a different kind of knot. I don't know if this knot has any particular name. I've not seen this any place before. One of those, I just kind of invented it because it works for model rocketry. I'm just going to call this a figure 8 knot. I'm going to push it through and then bring it around and bring it through again, and then over here I'm going to put the streamer through it. So it's going to be kind of a figure 8 pattern. I find this works really, really well. I could just put this through and pull the streamer through, but that will tend to pop apart. We've seen that that knot does not have sufficient tension to keep it together. It's going to pop apart, and I don't want that to happen. So again, I'm going to go down through the loop like this. Then I'm going to pull the loop through again from the opposite side. Oh, it's kind of hard to see. Looks like it's a mess, but again, if you think about the figure 8, I went through the loop this way, brought it down, came back up through the loop this way. And now this is sticking out here on this side, and I've got the streamer over here, and just put the streamer through. And what's interesting about this is that this particular knot, after I pull this big knot through it, there we go. This particular knot looks a little bit different, and it's similar to what we had before, but it's like both ends are tied together. So when you pull this tight, it stays put. It doesn't seem to slide around very much. And as always, as a Kevlar knot, you can pull it apart fairly easily. So this knot now looks really nice. It's tight and streamer's attached. So hopefully this is going to absorb the shock. So on the ejection charge, it's going to first pull on the streamer, and hopefully that's going to dissipate a lot of the energy. And then the nose cone is just going to be floating along the side. And then during flight, return, it's going to just simply yank on the rocket body because it's going to be much closer. And that, again, should help prevent the nose cone from zippering. But also I found that if you pull directly on the rocket rather than pulling on the nose cone through the cord, that this should flutter a bit more, so it might give a little bit more spectacular flight with fluttering around. When you've got this long shock cord in between, what happens is that the body flies off to the side and the body's tumbling, so the body does tumble and slow down. And the streamer is basically holding the nose cone and the blanket steady as a simple aerodynamic vehicle on its own. It's falling along the side. So there's really two things happening. We've got the nose cone on the streamer falling, and then we've got the body falling off to the side and the body sideways, which is nice. So it falls pretty slowly. It's got a little bit of a tumble to it. Then it lands on horizontally. So it lands like this, and I've never had anything break. But again, this would be a little bit different. It's going to yank on the body. The body's going to yank on the streamer, and these two are going to give a little bit more of a dance, and it's going to give a little bit more fluttering to it, maybe a little bit more special effects here. Okay, so that's it for this. That's the repair for this. I fixed the eyelet here, but I did decide to move the streamer down here and prepare for a flight the same way as before. Just wind all this stuff up, put the streamer in here. But again, the interesting thing is that as this ejects outward, the first thing that's going to happen is the streamer is going to go flying out, and that should hopefully absorb a lot of the energy from the ejection charge. Okay, so that's it for the venture, and I'm looking forward to launching this again on another C65 and just putting it up and seeing what it does. So that's it. That's the repair for this and a slight design change, and we'll see what happens. But again, that's the fun of rocket science. You can take a look at these problems and say, hey, maybe I can just change this around and make it work a little bit differently. And just for a quick follow-up, I did pull this much tighter. I simply pulled the knot that was in the Kevlar all the way through the loops, and now you can see it's a very, very tight knot, very close to the nose cone, tight over here. And all I did was feed it through the nose cone and the blanket, and then just put that one simple knot onto it. But you see, it's very, very tight, and this is going to be just fine. So this is really what you want it to look like when you're done, is to just pull the knot completely tight by pulling everything through, and you should be all set like this.